Unit 10, Lesson 5, Solving Equations Algebraically. That means we don't need the tiles anymore. We are not going to use the algebraic tiles, but we need to use the algebraic way only. And there is 3 methods to solve the equation with the algebraic way. The first method is inverse operations. So this is an example to show you what the meaning of inverse operation. We have 3x equal 6 minus x. Now, with the inverse operation, before I start, usually we are saying the best way is to keep all the variables in one side and all numbers in the other side. So as you can see here, 3x, this is the left side, and 6 minus x in the right side. So the first thing we can try to do is to add or to transfer this x to the left side and to keep all variables in the left side and the numbers in the right side. So let me try to do it. I have 3x equal 6 minus x. So as you can see from here, the variables in the left side, so I can think with this way that I need all variables in one side and the numbers in the other side. So inverse operation means what? How can I isolate the number 6 to make it by itself instead of having a variable with? Usually to do this we are doing 6 minus x, and I'm going to change the color to show you only what I'm trying to do. With the red I'm going to try to add x. So you're going to ask me why you are doing that. I'm doing that because I'm trying to make negative x, positive x together to have 0 pairs. So I'm adding x. Usually you cannot do this one from one side and you neglect the other side. So if the other side has 3x, you have to do the same change, add x from the left side. So no one can complain that you change the shape of the equation. You add it in the right side, you add it in the left side. So it's the same. Now, this one, it's gonna lead us to what? The minus x plus x, this one, it's gonna lead to 0 pair. So the result is gonna be 6. And the other side, 3x plus x, this is exactly like 3 apple plus 1 apple equal 4 apple, 4x. This is the first, you can say, step of the inverse operation. Now I have another problem. I still have a number mixed with variable and here numbers. So I can think that if I transfer the 4 to the other side, it's going to be better for me. So I need to isolate x. Now, how to isolate x? There is an operation between 4 and x. We said there is a hidden multiplication. For x means 4 multiplied by x. So to isolate x, that means I take 4x and I divide it by 4. I divide it by 4. Because 4, I can simplify it with 4. It's gonna give me 1, done. So I don't have anything beside x. But I cannot do this without doing the same thing with the right side. So I have to do the same thing. If I divide by 4 the left side, I have to divide by 4 in the right side. So I reach what? I reach 4x divided by 4 equals 6 divided by 4. Now this is better. Why? Because I can simplify 4 with 4. And this is gonna lead to x only, and this was my goal, to isolate x. 6 divided by 4, that means I can simplify, I can divide each one by 2, it's gonna be 3 over 2. As soon as I reach x equal 3 over 2, I solved the problem. So if you remember from last lesson, to solve any problem we need to find the value of x. But again, before I finalize or I say I solve the problem, I has to do the verification. Very important. So if I have a quiz, before I give my answer sheet to the teacher, I have to verify, is x 3 over 2 can transfer or can make my equation true? Let's see. So I'm going to substitute each x by 3 over 2 and see the result. If the left side equal to the right side, yes, 3 over 2 is the right value. So 3 times 3 over 2 equal 6 minus 3 over 2. So 3 times 3 equal 9, 9 over 2 equal 6 minus 3 over 2. You know, in fraction you need to have the same denominator. So 3 over 2 is going to stay as it is. Now to transfer 6 on something over 2, that means it's going to be 12 over 2. So 9 over 2 equal 12 minus 3, again it's 9 over 2. Wow. So left side equal to the right side. And this is to show me that the x equals 3 over 2 is the right answer. So we saw what the meaning of inverse operation. If here it's negative x, my inverse operation was positive x. Inverse. Again, I had 4x. 4 multiplied by x. The inverse is division. So you can see here, I can say that here addition was the inverse of the subtraction. And here the division was the inverse of the multiplication. That's why we call it inverse operation. But don't forget, whatever you do in the right side, you have to do it in the left side, or whatever you do it in the left side, you have to do it in the right side. So this was the inverse operation. The second method, we call it inspection method. Inspection method, it's something like you have to ask yourself many questions. 2n minus 7 equal 11. The first question, what is the number that you subtract from 7 to give you 11? And actually this is something that we faced in, you can say, grade 3 or grade 4. Whatever you have here, minus 7 equal 11, that means you add 7 to 11 equal 18. So 18 minus 7 equal 11. So that means that 2n equal 18. My goal is to find the variable n. Okay, another question. What is the number that you multiplied by 2 equal 18? Usually, to find this, we divide 18 by 2 to find the number. It's 9. So 2 times 9 equal 18. That means right away n is gonna equal to 9. And this is my discovery. Again, we cannot finalize everything before I do the verification to check if I found the right value for this variable. So I'm gonna substitute n with 9 and check if it's correct or not. 2 times 9 equal 18 minus 7 equal 11. 18 minus 7 equal 11 equal 11. That means left side equal right side. And this is the method of the inspection. Small questions. But the inspection method, it's not a perfect if we have a complicated equation. So that's why I prefer always the inverse operation. The last one, which is the systematic trial. Systematic trial, it's very long process, and you will find that you are not going to use it too much because we don't need to go far like that. Systematic trial, from the word trial, that means what? You try. You say what? I'm gonna try x equal 1. After that, you're gonna substitute 3 times 1 equal 6 minus 1. 3 times 1 equals 3. 6 minus 1 equal 5. Is 3 equal to 5? No, wrong. You try x equal 2, and you try 3 times 2 equal 6 minus 2. 3 times 2 equals 6, and 6 minus 2 equals 4. Oops, left side doesn't equal to the left side, and so on. You try till you reach the right answer. And this one is very long, so that's why we are trying to avoid. So as you can see, the preferred one is the inverse operation. Now, what can we learn from the inverse operation? So I need that you focus with the left side with the inverse operation. What can we learn from the inverse operation? What can we create to make it shorter and faster? If I have 3x equal 6 minus x, we are saying, instead of using the inverse operation that you can see it here, we can create something else. We can imagine that in the left side US and in the right side Canada. And this is not true, this is small imagination, okay? And imagine there is a border. And we are saying, if you want to go from US to Canada, you need to show your passport. And in this passport there is a visa. In our case here, you need to show your sign. If you are positive, to go to Canada side, you have to be negative. You switch. If you are negative, you switch to positive if you want to go to Canada. If you are a division, you need to switch to multiplication to be able to go to Canada. And if you are a multiplication, you need to switch to division if you want to Canada. And the same thing from Canada to US. If you want to change, you have to change or switch your sign. You will see if I'm doing this way, it's exactly like the inverse. So I'm going to show you now how we can do it. 3x equals 6 minus x. Again, I'm going to repeat it here. 3x equal 6 minus x. If you remember, in the beginning of the inverse operation, we said we need to switch this x to the left side to make all variables together. You're gonna ask the negative x, what is your sign? X will answer, I am negative. Okay, you can go to the other side if you are positive. So 3x positive x equal 6. If you look to this step, you will see exactly that this one, it leads to 4x equal 6, and this one exactly like this one. Can you see? We call this one inverse. This one, we don't need the inverse. We switch from one side to the other side with the condition that you change your sign. Let's continue. I have another problem. I have 4x equals 6. There is a mix between 4 and x, number and variable. I need to ask the 4 to go to the other side. I'm going to ask the sign of the 4. What is your sign 4, or what is your relation with the x? The 4 will say, I am multiplied to the x. So you are multiplication. We said you have to switch to division. So if you want to go to the other side, you become as a division. X equal 3 over 2, and this exactly was exactly like this step. So as you can see, the inverse operation, it's exactly like the US and Canada way, that we switch the sign if we want to go from one side to the other side. So I'm going to create another problem to understand this Canada-US way. And actually, mathematical, we don't call it Canada-US, but I created this example to make it easier for the student to understand the concept on it. 3 plus 2n equal 4. Again, instead of using the inverse operation, we're gonna use only to switch. So as you can see, number plus number multiplied by variable equal number. So the first thing we're going to say, why we don't switch the 3 to the 4 to the other side. I'm going to ask the 3, what is your sign 3? The 3 will tell me I'm positive. Okay, if you want to switch to the other side, you will be negative. Excellent. So 2n finally going to be equal to 1. Now I see a mix between number and variable. I'm going to ask the 2 to go to the other side. I'm going to ask the 2, what is your sign? What is your relation with n? The 2 will tell me I was multiplied by n. Because you are multiplication, you have to be as division. So n equal 1 over 2. And this is the final answer. If we need to do the verification, we can do it. Verification to make sure that my answer is correct. Verification. 3 plus 2, I'm gonna transfer the n, 1 over 2 equal 4. Let's check. 2, I can simplify it with 2 equal 1. That means 3 plus 1 equal 4. Left side equal right side. That means my work is correct. Now, someone will ask me, can you do the same thing instead of Canada US way or the switch way? Can you do the inverse and show me if it's the same? Yes, we will do it. We said the inverse, it was 3 plus 2n equal 4. My goal to isolate the 2n, I don't want to see numbers with variables, to isolate it. So we would say what? If the 2n is here, and I have 3 here, to isolate 2n, I need to remove this 3. That means I am looking for 0 pairs. So that's why we are saying, okay, we can say negative 3. I add negative 3 to this equation. And negative 3 with positive 3 together, they're going to be a 0 pair. But don't forget, whatever you are doing in the left side, you have to do it in the right side. So if you add negative 3, I have to add negative 3 in the right side. So as a result, 0 pair, bye-bye. So it's going to be 2n equal 4 minus 3. Can you see this one? It's exactly here. Here we switch it right away to become negative 3. Here we did the inverse way. But both they're gonna lead to the same thing, 2n equal 1. Here we go. Now I need to isolate n. I need n to be the left side and the numbers in the right side. So what we're gonna do, if 2n and I need to isolate n, that means I need to divide by 2. But whatever I'm doing in the left side, I have to do it in the right side. So I need to divide the same thing by 2. Here I'm isolating n by simplifying, so the result is going to be n equal 1 over 2. And this is exactly the same thing that I got it from the switch or the US-Canada way. So as you can see, both are the same. This one in the left side is faster, little bit. I switch right away and I know that I have to change the sign. Here is the same thing to show you why we are switching the sign. If someone tell you, this Canada US way, why you would change? Actually, it's coming from here. You can show him the inverse and you say that here, because I have to add the negative 3 to reach the 0 pair, that's why it becomes as negative 3. Here, to get or to isolate n and to get the simplification, I need to divide by 2. That's why when we transfer from 2 to the left to the right side, we have to divide. So both ways are the same, but it's only different strategy or different shape only. I hope you understood this lesson. Thank you.